Hey guys, today we're going to take a look at graphing with intercepts. So this is a new way of graphing by finding the x and y intercepts and using those 2 points to just draw ourselves a line. Okay, it's just an alternate way of graphing a linear equation. Sometimes it will be easier than using slope y-intercept, and sometimes it'll be harder. There's not necessarily a better version or a better method. Sometimes one's better, sometimes the other. You will notice that I've filled out most of my handout already because, of course, I had some technical difficulties, so sorry about that. But anyway, it means you won't have to watch me write as much. All right, so first of all, what is the x-intercept? Well, this is the point where the relation crosses the x-axis, hence the name x-intercepts. It intercepts the x-axis. The y-intercept, not surprisingly, is where that same relation crosses the y-axis. All right, so the first thing we're going to do here is we're going to take a look at this graph. And we've got 4 lines, okay, and I've labeled them A, B, C, and D. Okay, I don't know about that D. Let's try and, oh, won't even let me get rid of it. All right, whatever, it's fine. So we've labeled those, all right, and there are our points. So what I've done is I've gone through and I've said for line A, what are my x and y intercepts? So for line A, I'm going to use a different color than there so that you can see what I'm doing now. So that's where it crosses the x-axis. So that's my x-intercept. So I've got it down as -2, 0. Where does it cross the y-intercept? That would be at 1, 0. Or at 0, 1. Oh, my goodness. For line B, our x-intercept is at -4, 0. And our y-intercept is at 0, 4, or 0, -4. All right? So what you should notice here, which is what I've kind of summed up down here, is that a y-intercept is always going to have the form 0, y. If it's a y-intercept, the x-coordinate has to be 0. Similarly, if it's an x-intercept, the y value has to equal 0. So your answers, if somebody ever asks you for an x or y-intercept, you should always be writing the coordinates like that. And just make sure that you've got the right variable as the 0. All right? Now we do also have a vertical line and a horizontal line. So the horizontal line is line C here. And you can see that it crosses the y-axis at 0, 3, but it does not ever cross the x-axis. So there is no x-intercept. Similar thing for the vertical line. We cross here at 4, 0, but we do not cross the y-axis, and that's just a property of horizontal and vertical lines, is that they only have one of the intercepts. Okay? So, I know you guys like graphing, but you like algebra even more. So we're going to talk about how we can find the intercepts using algebra, or using our computation skills. So, what we're going to do is, first we're going to find our y-intercept. And the nice thing about this is that this works pretty well with standard form. So if you get an equation in standard form, often this will be the better way to graph it, or sometimes, I should say, not even often. Sometimes this is just an easier way to graph it. Not necessarily, but sometimes. Okay, so what we want to do is we want to replace the x with a 0, and this will tell us our y-intercept. All right. Similarly, if we let y equal 0, that will let us find the x-intercept. All right, so let's take a look at this first example here. We've got 3x plus 4y minus 12 equals 0. Nice standard form there. So we're going to start with our equation, but we're finding the x-intercept. So instead of a y value, we're going to write 0. Okay? And we say, what is 4 times 0? And the answer, of course, is 0. So we're just left with 3x minus 12 equals 0. So you can see, because that term became 0, it just disappeared. And because of the nature, if you're using standard form, that it's always going to happen, where you're just going to make one of those terms disappear. And now we just use our super algebra skills to solve for 3x. Okay, or for x, sorry, not for 3. First we'll find 3x. We move the 12 over to the other side. It's going to become positive. Okay, and then we're going to say, well, now we got to get rid of that 3, so we divide both sides by 3, and we get x equals 4. So there we go. Our first intercept is 4, 0. All right, so I can actually go over to this graph right now, and I can plot that point. So I had 4, 0, which is going to be, here, I'll use a blue here, right there. So there we go. There's our first point. But of course, we need 2 points if we're going to graph a line. So now we'll find the y-intercept. So we're going to start with 3 times 0 plus 4 times y minus 12 equals 0. And of course, just like before, that term that we sub the 0 into is just going to disappear because it's 3 times 0, which equals 0. So we're left with 4y minus 12 equals 0. Now it's just a matter of solving for y. So if we add 12 to both sides, or if we move the 12 over, it becomes positive 12. Okay, we divide both sides by 4. And we get y equals 3. So our second intercept is at 0, 3. All right. So that's going to be right there. And there we go. So now we have 2 points, which is all we need, and we are ready to graph this. So let's set this up, and oh, thought I had it. No, and now I'm missing the line. There we go. There we go. Graphing on this thing is hard. Anyway, it's using a ruler. That's what's difficult. Anyway, make sure you label your line. Of course, it doesn't matter where. We'll just put it right here. We'll say 3x plus 4y minus 12 equals 0. So there we go. So there's our first line. Okay. So we can do the same thing. Now this one I'm giving it to you in slope y-intercept form, okay, which is going to be easier in some ways, harder in others. I don't know. Usually using the y-intercept and the slope is the easier way to graph these, but we're going to do it this way just so that you can see that it'll still work, okay? It doesn't make a difference. Okay, so the first thing we're going to do is we're going to find the y-intercept. Okay, so to find the y-intercept, there's 2 things you could do. You could replace the x with 0, or you could just say, well, hold on a second. I know how to do that from the mx plus b stuff, and we know that the y-intercept is going to be 0, negative 6. All right, that's that same b value that we've been doing, right? That's the same as b. That is your y-intercept. Okay, so we don't have to do anything differently there. What we are going to do now is we're going to find the x-intercept, and we're going to do it a little differently than we would have done it in the past. Well, I guess we never did it in the past. We used the slope. So instead of using the slope, we are going to take the equation. Oh, no, that was not a... There we go. Okay, so there's our equation, and instead we're going to have a 0 instead of y, because we're finding the x-intercept. Okay, so I'm going to move the 2x to the other side. It's going to become positive. Okay, and then I need to divide by 2 to get the x by itself. So I get negative 3. So my x-intercept is negative 3, 0. So from there I can just plot those 2 points. So I had 0, negative 6 and negative 3, 0. So let's go negative 3, 0 and 0, negative 6. So there's my 2 lines, or my 2 points. And I'm going to try again with this ruler. Oh, I've got an idea. You can't tell what I'm doing, but I may... I got it perfectly, except that I used red. Did I use red? Yes, I did. Well, whatever. It doesn't matter. Red line, black line makes no difference. So we do have to remember to label this. So we'll call that y equals negative 2x minus 6. And that's it. So now you can see it's just another way to do the same thing we've been doing. But specifically with the standard form, often that can be a much faster and easier way to do it. All right. So until next time, go Sabres.